So, whatever we learned yesterday, I'm just curious, was that clear to most of you? Okay. So we talked about what do we mean by circle theorem. We re-looked at what is the concept behind area of a circle, perimeter of a circle, and how do we relate that information to find out the arc of a circle or sector of a circle. What we did not do was how to find out the segment of the circle. And I'll probably park that also for today because that will be little loaded to begin with, and there's some more concept that we would want to touch upon before we go there. Okay. So I see Neil has joined, Tanu has joined, and who else joined in between while I was just talking to myself. So yeah, Neil joined, and Sahib joined, and Tanu joined. Okay. All right. So let's get started. So I was saying that we talked about the circle theorem, where we looked at some of the properties of circle that we already knew. How do we find the area, perimeter of circle, and then how do we relate that information to find out the arc and sector of a circle. Yeah. And what we did not cover, we briefly touched upon what do we mean by segment of a circle, which if I try plotting on the board, I'm essentially talking about this being the circle. We have taken 2 points on the perimeter. Everything that you see as a slice of the pizza, that is called sector. The border of the pizza is called arc of the circle. And here I'm saying the minor arc. You can look at the major arc which is outside. Yeah. And then if you join the 2 points, let's say this is A and B, if you join these 2 points, then whatever you see as a shaded region here, that's called segment. And finding out yesterday when we talked about it, we said, okay, if I have to find out the area of this segment, what we need to do is find out the area of this triangle, find the area of this whole slice of the pizza, subtract this area of the triangle from the whole size of the pizza, that gives you this part. That part I did not say, I think it was Ritika who explained that, right Ritika?
Yeah.
Okay, so that is how you find out the segment of the circle. I'm not going into that, and we are not going to do much about finding the area of the segment for now, because I thought it will be a good idea for us to look at the unit circle trigonometry first. That will give us a little more insight into things, and then when we go inside this concept further to find out the area of the segment, that will make a lot more sense to us. Okay. So I see Praneeth and Sarani also joined. So good afternoon to everybody, and I know it's a good and a hot afternoon. So make sure that everybody stays hydrated before we start talking about what we are going to learn today. So whatever we learned yesterday, that is history, we'll learn something new today. Is that okay? Yeah? All right. So let's get started now. I'm talking about unit circle trigonometry. Again, something which might bother people because of the cryptic terms that I'm using. Unit circle trigonometry, 3 words together. But before we go there, let's look at something easy, which will be like a jump start for us, and then we will go to unit circle trigonometry. Okay? So we have been talking about angles like 0 degree, 0 degree, 30 degree, 45 degree, whatnot. So on and so forth. So we have been talking about angles in degree. Ludwig. Now there is something called, people say, okay, angle in radian. So this is degree that you see here. There is something called radian. Can somebody briefly tell me what exactly is radian and how does it come into picture? What is the understanding of radian degree, angle in degree versus angle in radian? Any correlation that you guys are aware of? Yes, Chris.
So like radians, they're usually like expressed in terms of pi, and they're usually relative to how many kind of rotations around a circle it takes. So like the 360-degree one rotation is usually 2 pi radians, and then after that like pi is like 180 degrees, and then like pi over 4 is like pi over 4 is 90, and then pi over
4 is 45.
Oh yeah, 45, sorry. Like pi over 2 is 90.
Yeah.
And then, yeah, like that.
So now, question to everybody. Is that the same understanding that we all have? I see Davik also has joined, Tanu joined back again. Are we all in agreement with whatever Chris said? And trust me, I keep on saying this, don't trust your best friend. Even if Chris is best friend for some of you or all of you, you have to have your own understanding of things. As long as whatever Chris is saying, you guys are agreeing to it, we are good. If you don't, no harm in arguing or debating about it. Priya, what do you say? You agree? Not to me, but whatever Chris said, did that make sense to all of us? That's a question.
Yeah.
Aswita, Nirunya? No? Yes?
Yeah.
Okay. So let me see, I am very good at muddling the water, right? I keep on saying the same thing over and over again. And that is because I want to make sure that even if there is slightest of assumption with respect to what we understand, we should knock it off. Okay? So Tanu, are you with me, beta, so far?
Yeah.
Okay. So now I will make it look like a simple equation. 180 degree and pi radian, both are same. Whichever way we want to read it, whichever way we want to read it. Okay? So degree and radian are two units of measuring angles. Okay? Somebody likes degree, somebody likes radian. We don't really want to worry about it. We just need to know the relationship, right? Like you all know that, okay, 12 inches make 1 foot. You can measure in inches, you can measure in foot, depending on what you are comfortable with. Or we all know that 2.51 centimeter is 1 inch. Same thing. If you are comfortable measuring in centimeter, use centimeter. If you are comfortable measuring in inch, you measure in inch. That's the thing. Now the point that Nikhil made was that we use pi when we are measuring rotation or iteration of the circular movement. Let's look at it. Now here, this is the thing. 180 degree is pi radian. So basically, if you look at this circle makes 360 degree. Half of the rotation, when you're looking at semicircle from here to here, this is 180 degree. This 180 degree, half of the circle or the semicircle, whatever you call it, makes 180 degree, and that is also given a name as pi radian. Now, if somebody says, find out how much is 90 degree in radian. Okay, 180 degree is pi radian. 180 is pi radian. 1 degree will be pi by 180 radian. 90 degree will be equal to 90 times of whatever is the value for 1 degree. So pi by 180 times 90. Now you do tic-tac-toe. This 1010 you can knock it off, and 18 you can write as pi into 9 by 18 you can write as 9 into 2. 9 and 9 tic-tac-toe, you have pi by 2. Yeah. So this is how, so basically we don't really have to worry too much about how to convert degree to radian, as long as you remember this one thing, or you remember this picture in your mind, that okay, half of the circle is nothing but pi radian. In degree it's 180 degree, in radian it's pi radian. pi radian. That's it. Does that make sense?
Yeah.
Yeah? Hello, Purvi.
Hi, sir.
You were missed in a couple of classes, but yeah. No, so see, it's not about anybody complying to watch the video. My only concern or worry is around if somebody misses the class, they have to watch the video. Watch the video is one thing, but never ever be shy to challenge your teacher. Let's say you watch the video and you did not understand something. It's not your mistake, it's my mistake because I did not do a good job. Always say, sir, you explained this to me, I watched the video, but this part is still not clear to me. So I would be very happy when you guys put me on this part and say, sir, I did not understand this. I don't want to assume that I'm the best teacher, okay? I'm not the best teacher. I'm just learning every day when I'm teaching you guys, okay? So don't be shy, don't hesitate. Praneeth will probably echo what I'm saying. Hello, Shiv. So Praneeth reached out to me sometime during this week. I think Tuesday. It was Tuesday. I was out for my daughter's Tuesday or Thursday. I don't remember exactly. No, it was Tuesday. So he reached out to me saying, no, sir, there's one question that I'm kind of struggling with. And whatever you taught me, that is not helping me. That gave me an opportunity to kind of break it down and explain it back to him. So I hope, I expect, I wish each one of you feel equally comfortable and reach out to me whenever you're dealing with tiniest of the problem. It has nothing to do with your ability to solve it or not solve it. It's always because the teacher has not done a good job of explaining it. Okay? Keep that in mind. The teacher is not good, not right always. Okay? All right. So just a message for everybody that when you watch the video, if anything that is confusing, please don't hesitate to ask me again. Okay? Yep. All right. So the kids who joined, can you hear me now, Shiv? Shiv, are you able to hear me now? Can everybody else hear me okay? Okay. Okay. I think Shiv was not able to hear me. So that's why I was asking him. So the thing is, there's a magic word for fixing that problem. Whenever you're not able to hear me, just disconnect and join back. That solves the problem most of the times. Let me. Yes, Shiv. Can you hear me now? Okay. All right. So for all the kids who, I think it was Purvi and Shiv who joined a little late. So whatever we have done so far is only one thing, that is converting degree to to radian. So if you want to measure angle in degree, we all know different degrees, and you have a tool which is called compass. Protector. Where did it go? Okay. Yeah. Where did that tool go? This is the tool I was talking about. I think it's called protector, right? So this is the one that is used for measuring the angles. Okay. So we measure the angle in degree, and that's what we have been comfortable with so far. But there's another unit for measuring it. 180 degrees is equal to pi radian. So if somebody says convert, tell me how much is 45 degree in radian. 180 is pi radian, 90 will be pi by 2, 45 will be pi by 4. And you can simply put a formula. Simply put a calculation. 100 degrees pi radian, 1 degree is nothing but pi by 180 radian. Now if you have to find out 30 degree, multiply by 30. If you find out 45 degree, multiply by 45. If you find out 90 degree, multiply by 90. That's it. So let's look at one or two problems, and then we'll go to unit circle trigonometry. And that is what I would want you to bother with. So let's look at some of the problems. I have a question here. It says, which of the following radian measure is equal to 135 degree? So you are given the angle 135 degree. How much is that in radian? That's what it says. First option is pi by 4. Second option is pi by 2. Third option is 3 pi by 4. Fourth option is pi. Any quick response to this question? 135 degrees, how much in radian? David, Praneet, Riya, Aswita, Nirunya, anybody? Purvi, Tanu?
I got C.
You got C. Did you calculate and find it out?
Yeah.
Okay. How about anybody else? You also got C. You also got C. Aswita, Nirunya, Thanu, Purvi.
I got C too.
Yep. Okay.
Got C.
Okay. Alright. See, I will tell you guys a dirty technique. Some of the problems you don't need to solve. This was probably one of those. Just now we talked about 180 degrees pi radian. We are not talking about 180 degree. Done. Pi by 2 into 180 by 2, 90 degree. We are not talking about this also. Two options ruled out. This is pi by 4, 180 by 4, which is half of 90. 45 degree. We are not talking about this. So we have only 4 options. 3 options are not right. This is called elimination technique. Many of the times you can solve the problem without solving it by just using common sense, and that will help you save a lot of time. But yeah, reading is not an option. You have to read. Analyzing is not an optional thing either. Nike is what you're dealing with. Yep. Ritika, Purvi, everybody with me?
Yeah.
Rehan? Okay. Sarah, Neil? Okay. Okay. So this was one easy problem, okay? Let's look at one more easy problem and then we'll look at something more interesting than this. Which of the following radian measures is equal to 45 degree? You are given 4 options. 45 degree. 45 degree in radian. Option 1 is given as pi by 2. Option 2 is given as pi by 3. Option 3 is given as pi by 4. Option D is given as pi by 6. Which one? Yes, Praneet.
C.
C. Nirunya?
I also got C.
C. David? C.
C.
Aswita, Riya, Dave?
I got C.
Yes. Everybody got C. C. There is nothing for me to do then. Okay. Thanu, Purvi, Sarah. Shiv, can you hear me now?
Yes, sir. I got C.
Okay, wonderful. Okay, so we are talking about how to convert degree into radian. Have you come across that before?
Yes, I've heard of it.
Okay, so there's nothing much to learn here. There is one relationship that we need to be aware of. So we are just doing a couple of questions. This is probably the last question before we go on to the topic that we want to cover today. So I was asking the kids, how much is 45 degree in radian? And not most of you, all of you have told C is the answer, pi by 4. Do you agree, Sif?
Yes, sir.
Okay. Here also use the same elimination technique. Pi is 180 degree. 45 is, pi by 2 is 90 degree, out of question. Pi by 6, when you look at it, pi by 2 is 90 degree. And this is half of 90, so pi by 4. Done. You don't have to do any calculation. If you still want to do it, put that in the formula. 180 degree is pi radian, 1 degree is pi by 180 degree. pi by 180 radian. Now 45, so multiply by 45, then do the tic-tac-toe. Now here some of you who have joined recently, who don't know what is the tic-tac-toe I keep talking about. Tic-tac-toe is a game that all of you would have played when you were small. And I lean on that for making life easier when it comes to doing mathematical calculation. And it is actually fun. If somebody says 13 into 19 into 21 into 15 into 75 divided by 25 into 9 into 7 into 26 into 5. The simplest approach would be you multiply this with this, then you multiply with this, then you multiply with this, then you multiply with this. And then once you have done all the multiplication for the numerator, then you look at multiplying all the denominators. You got one value here, maybe that was something like this, and then by doing this you probably got something like this. Now you divide this number by this number, that will be your answer. I don't believe in that. I don't like doing bigger calculation because that is when my chances of going wrong is more. So what I will do here is I will break it down and then play with it. So some of you who have played with it, please bear with me for 20 more seconds. Some of you who have not heard about this tic-tac-toe in the past, let's look at it. 13 is a prime number, I cannot break it down, so I'll keep 13 as 13. 19 is also prime number, I cannot break it down, I'll keep 19 as 19. 21, I can write as 7 into 3, nobody is stopping me from doing that. 15, I can again break it down to 5 into 3. 75 is 25 into 3. And then I have 25 here. Since I have 25 here, I'll keep 25 in place. 7, anyway the prime number, I'll keep it like that. 26 is 13 into 2. And 5 is 5. Now let's play. I have a 13 here and 13 here, tic-tac-toe. Make sure that you are doing tic-tac-toe when one is up, one is down, meaning one is the numerator, one is the denominator, okay? And make sure you're not doing tic-tac-toe in the same level. Then I have 7 here, tic-tac-toe. 25 here, 25 here, tic-tac-toe. 5 here and 5 here, tic-tac-toe. Then what I'm left with, 19, 3 into 3 into 3 into 3 divided by 2. See how cute the problem has become. 19 into 3 into 3 into 3 is 3 into 3 is 9 times 3 is 27. So 19 into 27. This is a much easier calculation that you would want to do compared to what we were seeing here like a monster. So tic-tac-toe is a technique which converts a monster into a puppy. I don't know if everybody likes puppies or not, but this is what I mean by tic-tac-toe. Meaning, when you have bigger numbers, try splitting them as factors and then you play with them to make your job easier. Does it make sense? Does it sound interesting? Aswita, Davik, Nironya? Yeah? Okay. So here, doing this calculation is much more fun compared to what we were dealing with earlier, right? So keep that tic-tac-toe in mind. That will stay with you till you have to deal with math, okay? That will make your life much easier compared to what you have to deal with otherwise. Okay? So let's forget about tic-tac-toe, let's forget about radian to degree conversion or vice versa. Let's look at unit circle trigonometry. Interesting. Who all knows about what is unit circle trigonometry? Let me first write it down. Unit circle trigonometry. And don't question me if you see a spelling being wrong, okay? I'm not really concerned about that right now. But unit circle trigonometry is what I'm talking about. What is that you guys know about it? Can somebody give me a quick story around it? Riya, Dev, Ritika, Nirunya, anybody. Don't be shy. You guys don't have to be shy with me, okay? Yeah, Chris.
Like you can use a unit circle to find out the sine, the cosine, or the tangent of basically like all the know what angles, and then you can also use it to estimate some other angles. So like if it was asking like what the cosine of 45 degrees was, like you could easily use the unit circle to figure out it's √2/2.
Okay, so you have given me a in-depth view of that. I'm still at the surface right now. I'm just trying to understand. Let's say if I don't know what is unit circle, how would I wrap my head around that? Any other story? I've heard Chris, and he has, whatever he has said, that is the perfect definition of it. But again, going back to my style of teaching it, I would want to relate that with basic English, make sure that we are very clear about it, and then we look at how do we apply it. Okay. Now Chris, I would give chance to other kids also. Let's see. Who wants to teach the teacher now? Davik, Riya, Shiv, Nirunya, Neil, Sarah, anybody? Hasvita? Don't be shy, guys. It's okay to make mistakes. I love mistakes. Ritika. Yes, Praneet.
So a unit circle is a circle with a radius of 1 unit. So you can use that to do what Chris said.
Okay, so yes. So now see, Praneet and Chris are helping me do my job better. Now, Chris gave me a very in-depth understanding of it, and Praneet told me how do I start. Now let's break it down first. Unit, what does unit mean? Yep, wait a minute. What? Go beta. So we are talking about unit circle trigonometry. We are just starting that, okay? So whatever you have missed, that was related to radian to degree conversion. You can watch that video and that should be clear. Right now we are starting with unit circle trigonometry. So unit means 1. Yep. Circle means face of your teacher. And trigonometry is something that we saw yesterday. Yeah. Trigonometry is basically when you are dealing with a right angle triangle, how do you find the relationship between the sides and the angle? That is what is covered in trigonometry. So now if we put these things together in perspective, when we look at the English part of it and then try putting our head together, this is a concept where you use a circle which has a unit radius, meaning radius of 1 centimeter, like what Praneet said. And you use the trigonometry concepts inside that to go to the next level of understanding. And let's do that. Now, so it's a circle with unit radius or one radius, be it 1 centimeter, 1 millimeter, 1 kilometer, 1 mile, doesn't matter, it's 1. So let's say this is my circle where the radius is from here to here or from here to here is 1. Let's say for sake of argument, we'll say this is 1 centimeter. Okay. So unit circle is what we are seeing. Now we are talking about unit circle trigonometry. So trigonometry will come into existence only when we have a right angle triangle, right? Meaning one angle is 90 degrees. Am I making sense so far? So we got a unit circle, meaning the radius is 1 unit and it's a circle. We are trying to add a third word in the matter of debate for today, that is trigonometry. And for trigonometry to come into our chain of thought, it has to be right angle triangle. So let's draw a perpendicular from here to here. This is not a perpendicular. See, this is where you guys will feel bad for your teacher being so horrible with his drawing skills. Okay. Now this looks better. So what did I do? I dropped the perpendicular from this point. So this is my radius and this is also my radius. These are 2 points on the perimeter. Okay. And let me do one thing. Let me give you guys a picture of a coordinate plane. So let's say this is my x-axis and this is my y-axis. This circle is drawn in the coordinate plane where the center of the circle is coinciding with the origin of the coordinate plane. Yeah. So this is x-axis, this is y-axis. Is that making sense so far? Now, here, from this point I have drawn a perpendicular so that this is 90 degree. Now if you guys remember, if you are talking about this point, it's in a coordinate plane. What is the x coordinate and what is the y coordinate? That is what you have to find out, correct? X coordinate will be this length and y coordinate will be this length if you are looking at it from a coordinate plane, correct? I'll go slow because this will take some time to digest this, okay? So, but Davik, Sahit, Dave, Hironya, Hasmita, Tanvin, everybody, are you guys with me? Riya, Neil, Sarah, everybody? Chris, I know you are a little ahead of me, but am I going so far fine? So, this is the journey so far, right? So, we said unit circle trigonometry. So, we looked at a circle with radius as 1 unit. I'm saying 1 centimeter for now. And then, in this circle, I aligned this line with the x-axis. So, basically, the x and y axis are meeting at the center of the circle, or this is the origin. So x and y coordinate both are 0 here. So this is here to here will be my x, here to here will be my y, right? Since I picked up this point here, I don't know where did I pick it. If I could have picked it here, that would have been different. So let's say this is angle theta. Okay, this angle is theta. So, if you guys remember your SOHCAHTOA, which is sine theta equal to opposite side by hypotenuse. This is my hypotenuse, right? If you look at this right angle triangle, let's say O, this is A and this is B. In right angle triangle OAB, my sine theta is this, sine theta will be this height by hypotenuse. So y by hypotenuse. Hypotenuse is 1 centimeter. I'll write 1. You can write 1 centimeter also, that's fine. My cos theta will be equal to cos of theta. This theta will be cos theta will be adjacent side, which is this, divided by hypotenuse. So x divided by hypotenuse. X divided by hypotenuse, which is again 1. So now look at this. Sin theta equal to y by 1, which is y. Cos theta equal to x by 1, which is x. So your x coordinate is cos theta, y coordinate is sin theta. I will replace x with a cos theta and y with a sin theta. Why we could do that? Because we use a unit circle where the radius of the circle is 1. And that became a rule of thumb for us. If you are talking about a circle, any point you pick on the circle, if you are picking up this point, this makes this angle theta with the horizontal axis or x-axis. That point will be cos of theta will be the x coordinate and sin of theta will be the y coordinate. And that is the basic rule of thumb that we need to use when it comes to sin theta and cos theta. Now you guys will start thinking that, sir, why do we have to actually stress ourselves so much so to worry about this? SOHCAHTOA was enough. SOHCAHTOA, it took us 30 seconds to memorize this. Why we are going to one more level and worrying about this unit circle? Why do we need unit circle trigonometry? Trigonometry is enough. Circle is enough. Let's keep them separate. Why to worry? The advantage here is, see, if you remember, when we were talking about sin theta, cos theta, tan theta, our maximum angle was going up to 90 degree. Okay? Because when you go beyond 90 degree, your trigonometry falls apart. Your right angle triangle goes for a toss. You cannot have one angle is 90 degree and this theta being 95 degree. Not possible. But is trigonometry limited to finding the value of sine, cos and tan theta only till 90 degree? Answer is no. This is where this coordinate plane, the circle in the coordinate plane, the unit circle in the coordinate plane, and applying that theta comes out handy. Now, this theta, see, if you're talking about this point, let's say this point is making 90 plus 45, 135 degree. Your unit circle formula will still apply, and you'll say, I don't really care whether it's in this quadrant, this quadrant, this quadrant, this quadrant. Wherever it is on the circle, my x coordinate will be cos theta, y coordinate will be sin theta. That's it. And here we are talking about cos of 135 degree, sine of 135 degree. That you cannot achieve by using the basic trigonometry. Okay? Because trigonometry limits it to, if you go by the basic concept of trigonometry, you are talking about right angle triangle. Right angle triangle. Your triangle is a right angle triangle, meaning one angle is 90 degree already, second angle cannot be beyond 90. Otherwise, it will kill the basic concept of a triangle saying that sum of all the angles is 180 degree. You cannot have one angle 90 degree and another angle more than 90 or even 90 for that matter. But here, using the unit circle theorem, tomorrow if somebody says, find out sine of 750 degree, this will come to our rescue. But before I prove what I'm saying, are we clear with whatever I have said so far? I mean, has that made enough sense to everybody? Danvin, Chris, Ria, Save, everybody? Yeah? Hasvita? Yeah? And trust me, kids, okay? But make sure that you are not saying yes because your friends are saying yes, okay? Ritika can have a different point of view, Pranit might have a different understanding. It's okay. I'm here to bridge the gap if there is one. Okay? Yes, Tanvir.
You said if one of the angles is 90 degrees, the other angle cannot be above 90, then how do we find the sine of 750 degrees?
So that's where you switch from right angle triangle to unit circle. Yeah? So right angle triangle, see, you can never have a right angle triangle with one angle being 750 degree. That literally wipes out the identity of a triangle. Any triangle that you talk about, any triangle, be it a triangle that I have created versus you have created, or Hasvita has created versus Chris or Pranit has created, you can never have a triangle with sum of all the angles more than 180 degree. Never ever. So now then, are we saying that our trigonometry is limited to only 90 degree? This is the solution for that. So before I go further, okay? Now let's look at it. How will you wrap your head around this? So whenever you are dealing with sine or cos or tan of, or even cosec, sec or cot of any angle more than 90 degree, you will switch away from right angle triangle, jump onto unit circle. Okay? Because that is the way. And unit circle, by looking at this, whatever we have seen, it says that your x, any point on the circle, be it a point here, 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 its coordinates are cos theta and sin theta. X coordinate is cos theta, y coordinate is sin theta. Okay? Now if you are talking about 45 degree, you are here in this first quadrant, meaning your x value is positive, your y value is positive. Yeah? When you are talking about 135 degree, you are in this place. You will see that your x becomes negative. This is your x coordinate, right? X coordinate. x becomes negative, y becomes positive, y still remains positive. If you come to third quadrant, let's say you're talking about 235 degree, 180 plus 45, 225 degree. You are in this quadrant where your x value and y value both are negative, right? By the coordinate geometry concepts, correct? Yeah. So there are two parts to it. One is the length. Your x coordinate is nothing but the absolute value, length. Y coordinate is your absolute value of this height. So if you are here, we are talking about absolute value of this as a y coordinate, absolute value of this as a x coordinate. And since you know that you are in the third quadrant, you will, whatever absolute value you get, you will put a negative against that. That becomes your value here. Okay? So let's do one thing. Rudra, sit down without making a noise. You are 17 minutes early for the class. So you are here but you are not here. I don't want to hear even a pin dropping. Yeah? Okay. So okay, I got distracted. So basically, let's first look at the concept part of it. Okay? What are the key takeaways before we even kind of try getting into the depth of it? But so far, whatever we have talked, Tanu, Purvi, Chris, Praneeth, everybody with me, right? I'm just checking in between, okay? I might get lost in my chain of thoughts without bothering about you guys. That's why I'm just stopping in between and checking. If Ria is okay, if Niranya is okay, if Hajita is okay, everybody is with me so far, right? Shiv okay? Okay. Now, so there are two takeaways that we want to keep with us first. This is a unit circle. Unit circle is nothing but a circle with radius as unit. I said a pin should not be dropping even. Be careful. Okay. So it's a unit circle, and to keep the picture in our mind, this circle is equally divided among these four quadrants. This is my x-axis, this is my y-axis. So what I said was, a rule of thumb hereafter is, any point on the perimeter, x coordinate will be cos theta and y coordinate will be sin theta. That's it. Now you find out the theta. This theta is nothing but the angle that it makes with the positive x-axis. Okay, positive of the x-axis. So find out this theta, put it here. That's it. And we all know, if you just look at it from a coordinate geometry perspective, your x coordinate is the length, absolute length of this in the x direction, and your y coordinate is the absolute length in the y direction, and then depending on which quadrant you are in, you put a positive or negative to it. Okay. So now let's look at one situation. Now before we do that, let me put a small table, because I want you guys to memorize something which I don't prescribe, but we will still end up doing that because that's going to be our survival technique. And we have talked about how do we prove these values, but these angles will be so very frequently coming to us that we'll end up memorizing these values. Sin 0 is 0, sin 30 is 1 by 2, sin 45 1 by root 2, sin 60 is root 3 by 2, sin 90 is 1. Cos 0 is 1, cos 30 is root 3 by 2, cos 45 1 by root 2, 1 by 2, 0. And then sin by cos is my term. Okay? So I'm only focusing on sin and cos for now. But some of you who have not seen me doing this gymnastics will probably think, how come these values have come into existence? But when we do that, when we do it again, we'll be clear about it. Some of you who are baffled right now thinking from where these values came, send me a text message on WhatsApp. I'll send you the video of that class so that you can just go through it to understand how these values were derived or arrived at. Okay? So here, sin 0 degree is 0, sin 30, all these values, we'll keep it here for now. Now if you're talking about sin 45 degree, here let's say if this theta is 45 degree, this is x coordinate is going to be cos 45. Cos 45 is how much? 1 by root 2. and sine 45 is 1 by root 2. Done, no problem. So this length is 1 by root 2 and this length is also 1 by root 2 because 45 degree we are talking about. If you go to this point, okay, look at this, look at the correctness of this trigonometric ratio or unit circle trigonometric concept. This point, again, whichever point you're talking about, it has to be cos theta and sin theta as x and y coordinate. So what is the x coordinate? Cos theta. Okay. So cos 90 degree and sin 90 degree will be x and y coordinate when you are making 90 degree. When you look at the coordinates of this point, get the value from here. Cos 90 degree is how much? 0. Sin 90 is how much? 1. See, that aligns. Your x coordinate is 0 on the y axis. Yeah? Your y coordinate is 1 because this is the radius of the circle 1. Isn't it? There's a correlation here. Are you guys with me? Yeah? Now, let's make another trip to this place. When I'm here, again, same thing, nothing changing for us. Any point on this, cos theta and sin theta. Here this is 180 degree from this horizontal x-axis, positive direction. Cos 180 degree and sin 180 degree. Now here if you see, what will be the value of, see, when you came all the way to this place, what happened? Your y coordinate is literally 0 because there is no height here. This whole thing turned this much that there is no height. If you are visualizing this as a right angle triangle, there is no height, this is 0. So this height, which is your y coordinate, is 0 here. So cos 180 degree and y coordinate is 0, so it's 0. So here you saw sin 180 is actually 0. So far we were knowing only till sin 90 degrees as 1. Sin 180 becomes 0. Similarly now cos 180. Cos 180, here to here it's minus 1. Right? Cos theta is your x coordinate. And this is the absolute value is 1, but in the negative direction. So these are your coordinates, and from this you found that sin 180 is actually 0. Cos 180 is actually minus 1. That is where the unit circle concept comes very handy, that you don't have to worry about anything. Let's say you're talking about this place.
Could you repeat how we got cos negative 1? Okay.
Okay, so so here this point, okay, when this makes 180 degree, right? This point's coordinates will be what? Cos 180, x coordinate will be, because my unit circle theorem says any point on the perimeter will be cos of that angle as the x coordinate and sine of the angle as the y coordinate. Correct? You know that your y coordinate is 0 because this line has moved and hit back the horizontal line. So there is no height here. Even if you are visualizing this as a right angle triangle, this angle is 0. So this line is literally falling on this. So this height is 0. Yeah? So sin 180 is actually 0. Yeah? What is your cos 180? That is nothing but this length. How much is this length? 1 unit because it's a unit circle. But you are in the second quadrant. Your x value is actually negative. If you visualize this number line, this was your 0, this was your 1, this was your minus 1. Yeah? So, now if somebody says, find out the value of sine 405 degree. Sine 405 degree. You look at the unit circle. You started from here, covered up to here. You got 360 degrees. Then your second loop starts. 360 plus 45. That's what you're talking about. You completed one loop and then you travel for another 45 degrees. That's how you landed here. This is no different from your sine 45 actually. Yeah? So again, here this absolute value will be the length of this one for x coordinate and length of this one at the y coordinate, and since this is in the first quadrant, both will be positive. It will be, now you look at this as a right angle triangle with this angle being 45 degrees because you already covered one loop of 360 and then you only look at this right angle triangle. Make sense? Tomorrow if you have to find out sine of 2515, you will see how many iterations of 360 you can, because after every 360 it gets reset. 1 360, 2 iterations 720, 4 iteration 1440, 5th iteration 360 plus, that is 1800. Yeah. Now you are left with, okay, 2 more iterations. So basically you will see 2015 has how many iterations of 360 into how many, and then you will see what is the remaining, and then you can visualize that, okay, am I talking about this triangle, am I talking about this triangle, and based on that you can find out the absolute value, look at which quadrant it's falling into, find out the absolute length and put the sign, and then you are done. Did that make sense to some of us? Niranya, Dhanven, David. So, let's see how much time we have. We still have 6 more minutes. So let me simplify this. Now when you are looking at a unit circle theorem, a unit circle trigonometry, it says one simple thing, that your circle gets reset after every 360 degrees. And that is correct, right? So if you have this circle, if you have to find out any angle, it starts from here, 90 degree, 180 degree, 270 degree, 360 degree, done. You are making a fresh start after every 360 degree. So if you have to find out the value of sine 380 degree, you will say, okay, from this I will subtract 360 because after every 360 it's reset for me. I'm only talking about 20 degree. This 20 degree is what I'm concerned about. From this triangle, find out this length and this length and this length. And so basically I'll find out to find out the x coordinate, I will say cos of 20 degree and sine of 20 degree as my y coordinate. That's it. So basically, any large angle that you're talking about, subtract, or every iteration of 360 degree you can minus from that, and the remainder is what you are concerned about. Because see, even if you are taking 10 iterations and then you are coming to this point, your x coordinate and y coordinate value, absolute value will not change. Whether you are coming after 2 iterations here or whether you are coming here after 20 iterations, your absolute length doesn't change. And that is exactly what is your geometry says. Yeah. So unit circle is a means for us to deal with larger angles, and in unit circle theorem or unit circle trigonometry gives us that ability to deal with larger angles, because if you are relying only on right angle triangle, we are limited to up to 90 degrees only. Yeah. Does that make sense to everybody? And does that give me an opportunity to take a sip of water while you guys are thinking? Ritika, clear beta? Riya? So, in layman's term or in your teacher's term, right? I'm pretty much a layman. I look at math as a layman's subject. and keep it as simple as possible so that it doesn't boggle us too much. And my approach is, we are calling unit circle trigonometry, call it, nobody is stopping you from doing that, keep calling it. But for me, after every 360 degree it gets reset. If I'm talking about anything less than 360 degree, okay, let's say if I'm talking about 300 degree. So from here to here is 100, 180. Here to here becomes 270. If I'm talking about 300, I'm essentially talking about 270 plus 30 here. But my calculation revolves around the horizontal x-axis. So if this is 30, then this is 60. I will treat this as 60. I will treat this as a right angle triangle. I will treat this as a right angle triangle where this radius is 1 for me, this radius is 1 for me, and this is 60 degree. This is 30 degrees. I will use this 30 degrees to find out this length. This is the vertical length, the y-axis. So this will be 1, so y value will be, absolute value of y will be sine of 60 degree, which is root 3 by 2. Absolute value of x will be sine of 60, what am I saying? Sine, yeah. X will be cos of 60 degree, which is 1 by 2. So this length is 1 by 2, this length is root 3 by 2. I'm just talking about absolute value, okay? And so I got my x value is 1 by 2 and my y value is root 3 by 2. I just got this value, my x value and y value. Now my y is negative because it's in the fourth quadrant. My y is negative, I'll put a negative here. My x is still positive because fourth quadrant still has x coordinate as positive. So I'll keep it as is. So here my sine, this was sine 300 degree and cos 300 degree. Those were the coordinates. So cos 300 degree is 1 by 2, sine 300 degrees minus root 3 by 2. Done deal. Praneeth, hold it. You are a little early for the class. I'm dealing with much older kids right now. Just give me 2 more minutes, then we'll start your class, okay? Everybody from level 1, please hold your horses for 2 more minutes before we start. Okay? So this is the advantage with unit circle trigonometry. It just helps you visualize the angles in a different way. Keep resetting your angle after 360 degrees and then find out the absolute value and then see which quadrant you are falling in, and then see, without doing much we could find out what is the value of cos 300 degree, what is the value of sin 300 degree. Tomorrow somebody says find out the value of sin 950 degree, you do the same thing. How many iterations I'm doing to reset it, then what I'm left with, and then which quadrant is falling in, and then draw the triangle and find it out. Make sense? Davik, Sahib? Yep. Irunya, Hashwita, everybody? Danvin? Ritika? See? Now the kids are from the next class are super excited and waiting for you guys to go, and I'm sure that makes you guys happy as well. So I'll let you guys go. Enjoy the rest of your evening. I'll come back haunting you guys next week, Saturday.